Okay, hello. Thank you very much for coming here. Second day after lunch, talk about artifact transforms. This is just a success for us. We were thinking that nobody's going to show up, right? So technical thing. Okay, we are going to discuss about artifact transforms. My name is Inaki Villar, working as solutions engineer for Velocity.
And I'm Nelson, lead solutions engineer on Velocity. And I've also previously an Android engineer. I mentioned that because, well, yeah, there's a lot of talks, and we're not just here to pitch a sales talk. We used to be Android engineers as well. I also maintain a couple of Gradle plugins, including Fladle and the Gradle Doctor. Yeah, so let's get started. Before we dive into the depth of artifact transforms, we want to explain a little bit about developer productivity and just explain one thing that, yeah, Velocity used to be Gradle Enterprise. So if you know it as Gradle Enterprise, it's now called Velocity. So on the solutions team, what we do, we help teams across the board from 50 engineers all the way to 10,000 engineers. We help them upgrade and optimize their builds. We help them migrate builds, scale their builds, all sorts of things. We also work a little bit in the Gradle ecosystem. We fix issues in open source plugins, especially when we see that with our customers. And we also report issues to Google and JetBrains when we see those types of things in customers. So yeah, now a little spiel about developer productivity. So yeah, as an Android developer, you probably spend a lot of time building, waiting for the IDE sync, all those sorts of things. So you probably experience the long development cycles and this sort of, as your productivity goes down, the cost of the company goes up. If you have hundreds of developers across the company, it's very expensive. So at Gradle, we're pioneering a developer productivity engineering. It's a new software development practice used by leading software development organizations to maximize developer productivity and happiness. So that's what we're here to pitch. And it's all about capturing toolchain data, accelerating and stabilizing your builds, and also measuring the impact of improvements. So when you make improvements to builds, you can measure what you did. So speaking of measuring, if you're in a plane, you often have there's a lot of instruments and dashboards in the cockpit, and not knowing your builds is kind of like not having any instruments on a plane. And even if you only have one instrument on your dashboard, right, the airspeed, you're missing quite a lot of information, and you can't really fly a plane without also knowing the altitude and things like that. So what Velocity, what we like to say is it gives you the whole instrument panel failure analytics for all your builds, so you can be more efficient. Speaking of inefficiency, so just like a little bit of math, if you have 60 seconds of waste in your build, and each developer on the team does 50 builds per day, and you have 50 developers on your team, that already is 42 hours lost of productivity per day. We also have a ROI calculator where you can type in numbers for your builds and kind of see how much wasted time and money that is on your organization. All right, so enough pitching. Now we're going to get into artifact transforms. So this is going to be a very technical talk. I hope you guys are excited for that. So artifact transforms, what are they? Before I get into that, actually, how many people are familiar with Gradle tasks? Okay, good. And how many people are familiar with transforms? Okay, just a few. All right. So we need to explain a couple of things first before we get into transforms. First thing is variant attributes. So what are these things? They give semantics and variants to Gradle to find the best matching variant of a dependency. So let's say you have a dependency. There's a standard set of attributes that are part of that dependency. For example, org.gradle.jvm version. You can imagine a dependency can be produced with a JVM version 8 or 11 or 17, and they can all be present on your system, and having a variant attribute helps Gradle grab the best matching variant for what you need. There's a bunch of different standard attributes that are part of the Gradle ecosystem. There's native architecture. You can, for example, have an x86, ARM, that sort of thing. Another attribute that I'm going to talk about a lot in the talk is the library elements. So you can imagine you have a dependency in the form of a jar, but it can also be in the form of classes, or it can be in the form of a DEX. So the library elements classifies whether a dependency is a jar or classes or any other format. So let's do a simple transform example. An unzipped transform can convert a jar into classes. Let's say you start with a jar. That's org.gradle.libraryelements equals jar. That's the attribute. You run the unzip transform because you want the output library classes equals elements, and then you have your classes. So that's a very simple transform. And now it's where it gets complicated. So transforms are a unit of work in Gradle, just like tasks are a unit of work, except artifact transforms only have a single input, which is the dependency artifact, but they can have one or more outputs. Just like tasks, they can be cacheable and they can be up to date. They fit into Gradle's dependency management engine, and they modify a dependency before it is used or consumed by a task. And what does a transform do? It modifies the dependency attributes. We're going to get into that in a little bit. What's also really interesting about artifact transforms, and the main reason that they're different from tasks, is that they allow the reuse of already transformed artifacts among several different tasks. So as an example, if you've already unzipped a jar to transform it from a jar to classes, and let's say your debug variant needs it and your release variant needs it, you don't need to do that work again. Or let's say you already dexed dependency, you don't need to dex it again if another task already did that. And that's the main reason why artifact transform exists. Some examples in the Android ecosystem include the Jetafire transform, the dexing transform, extract AAR transform, build API class path entry snapshot transform. We're going to get into more of the details of what these do, but for now, some more details. So build authors do not directly request artifact transforms. So with a Gradle task, you say, hey, run this task, but you don't say, hey, run this transform. What you do is you request a dependency with a certain attribute, and then Gradle automatically schedules transforms between units of work in order to get you that dependency. And transforms can depend on tasks or on transforms to form a chain of transforms. So I hope I didn't lose everyone. There's a little bit more terminology before we dive into the talk. So the first one is a transform action is the code to implement a transform. For example, extract zip or the dex transform class. A transform step processes the result of a previous transform. So like I said, you can have multiple transforms in a chain. A chain is a series of transforms. And a transform execution is the actual act of running the transform action. And a transform execution can also be avoided if it's, for example, coming from the cache or already up to date. And artifact transforms are now visible in build scans. You have to be using the latest version of Devvelocity, the Devvelocity Gradle plugin, and the Gradle build tool to see this. And that's why we did this talk, because now that we can see them in build scans, things get very interesting. Just an example, if you do a build scan, actually, how many people are familiar with build scans here? Okay, we got a good amount. I'm sorry if you aren't. I didn't want to turn this into an intro to build scan talk, but run your build with --scan and you'll get a build scan. If you're looking at the timeline, you can now see there's next to the tasks, there's the transforms in unit of work. And this highlighted here, that's one of the transforms, and you can see what the dependency attribute that it had, and you can see the duration. You can also see all the different attributes that are part of that transform, You can see the source and the target attribute and how it changed when that transform was run, and then, yeah, once again, the duration in the bottom corner. You can also see the different dependencies for that transform. So here on the predecessors tab, right, you can see that this transform depended on tasks and also other transforms. And what this also does is it fills gaps in the timeline that previously were just kind of empty because the build scan timeline only showed tasks, but now it shows both tasks and transforms. And yeah, the other thing you get is failed transform, so you can also see that in the build scans. And with that, I'm going to hand it over to Inaki for the next section.
Thanks, Nelson. In this section, we'll do a quick overview about how to create artifact transforms. Similar to task types, an artifact transform consists of an action and some parameters. The major difference to custom task types is that the action and the parameters are implemented into separate classes. The implementation of the artifact transform is a class implementing the transform action. You need to implement the transform method into the action, which converts an input artifact into 0, 1, or multiple output artifacts. Now, so look like the annotation input artifact that is used to inject the artifact to the transform action. The implementation of the artifact transform needs to register its transform output file with dir or file. Parameters are implemented in a separate class, as I mentioned. In this example, we are declaring just an input, and then in the transform action, we can access this input with the parameters property. If we want to make the transform cacheable, we need to specify a normalization method like the path sensitivity to the input artifact. Additionally, so an input at the end is a dependency, right? So if you need to access the dependencies of this artifact, you need to specify a file collection to access those transitive dependencies. So when the artifact transform runs, Gradle will inject the transitive dependencies in this file collection. So important to mention that you need to annotate with input artifact dependencies. So I mentioned artifact transforms can be cacheable, so you can use the annotation cacheable transform, of course. You can disable the annotation, the transform, cacheability as well. And finally, how to register an artifact transform. We need to use the register transform within the dependencies block. And of course, if we have declared parameters, we need to indicate the parameters. And the only required parameters are the from and to. As Nelson explained before, an artifact transform is going to move from a jar input to a class's output. So that's, in this example, artifact type, jar, and new attribute. And finally, so we need to register the action that's going to trigger the artifact transform. In this example, saying that for the artifacts of the runtime configuration of this task, custom task, I'm going to require that the dependencies have the new attribute, which means that I'm expecting that. So Gradle, in order to execute this task is going to say, well, this task has these input artifacts and is requiring a new attribute. It's going to look if I have a transform register for this combination, jar to new attribute. If not, you have a build exception with the variant dependency not found. I guess that's something typical that you have seen in your builds, right? Perfect. Now that we have covered the theory and how to implement artifact transforms, maybe this is like some advanced topic and you are wondering why we are talking this about the Android builds. So in this section, we'll see how artifact transforms are widely used in our Android builds. Let's start with the typical example. Always we are using now in Android from Google, always for everything. And let's execute an assemble build. So the expectation of this type of build is to execute around 2,000 tasks, I think. So the number of artifact transforms executed for an assemble debug in a now in Android is 5,000. So this panel, or this graph, represents the number of artifact transforms executed by type. So that's more than evident that we are using artifact transforms in our Android build. So from where come those transforms? Well, from the main actors of our Android build, the Android Gradle plugin, Nelson mentioned before the Dex transform, Jetify transform, Kotlin Gradle plugin, and additional plugins like Hilt. Let's start with the Android Gradle plugin. So I would say that the Android Gradle plugin, it's the Gradle component with the most usage of artifact transforms. And honestly, I think that the term artifact transform in Gradle comes because Android requested that. So I mean that's something that is in the nature of the artifact transforms. So we have more than 20 or 30, and honestly, I think that it's a little bit complex. And I couldn't be the right person to discuss about the internals of the transforms in the Android Gradle plugin. Also, I think that it would take like 1 or 2 hours. Instead, we are going to do an inverse exercise where, focusing in one particular dependency, we will analyze its path in terms of artifact transforms. So from the now in Android, I'm getting like the accompanies dependency, and we have 20 transforms for the same dependency. If we put like a diagram like this, this is just a glance of what's going on, so it's not the 20. We can see that the input, the initial input artifact is an AAR, so the dependency itself. The first transform action that executes is the extract AAR transform. But as you can see, we have several. Some observations from this graph. Multiple transform types have been executed. So it's not just one from one dependency. From the same dependency, we have like, I don't know, 7, 8, 9, whatever. We can execute the same transform type generating different output transforms. Look on the AAR transform on the top right corner. From an Android Explode AAR, we are using the AAR transform type to generate different outputs. And we can use, of course, the same input artifact in different artifact transform views. So, okay. I want to mention as well, that maybe is like a little bit abstract, but you can see on the Android classes that we have one transform that goes from Android classes jar to Android Dex with the dexing with class path transform. And dexing, I would say that if we are here, that's something that we know. We are familiar, right, in our build process that we require the dexing. So that's being closer to what we know. Okay, let's do another exercise and let's analyze one specific flow. In this case, is Android Explode AER that is requested by an AER transform to convert to an Android manifest. If we go to the build scan, to the transform request or transform executions, on the details of the transform, we can see the details. That's something that we'll see later. But additionally, we can see which task requested this transform. So for the AER transform Android manifest, we have that this process debug main manifest. So if we go to the timeline, to the task, we can see which type is. So in this case, process application manifest. So if we repeat this process for all the transform displayed in the diagram, we have something like that that is more clear and understanding that what's going on. So which task actually request these transformations, these transforms, right? For instance, again, going back to the Dex merging task. So with the Dex merging task, we know that, for instance, one of the types is, one of the implementations is merging external libraries, right? Merging the Dex of external libraries. So these libraries are maybe in a format, in a jar format. So the Dex merging task wants dependencies with the Android Dex attribute. That means that the Dex with class path transform is going to transform this Android classes jar to an Android Dex for later being processed by the Dex merging task. So This is just the surface, right? So again, you have in the cs.android.com all the available code of the Android Gradle plugin, and comes like a little bit complex, but just let you know that the Android Gradle plugin, everywhere, there are transforms everywhere. And of course, we have the Kotlin Gradle plugin, right? So as well, that's our main component as well with Android Gradle plugin in our builds. And we are using artifact transforms too. So if we are looking in the transform execution and we search by namespace of the JetBrains, right, Kotlin, we can see that we are executing tons of different transforms related to, it's called class path entry snapshot transform. If you are using Kotlin 2, there is a different name, but it's the same transform. What are doing those transforms in our builds? So this is related to Kotlin, incremental compilation from the Kotlin Gradle plugin. So Gradle can track change on the Java application binary interface, and this feature is known as compilation avoidance. But Kotlin cannot reuse the same model, right? So Kotlin is generating inline functions, so whatever, right? So we cannot, the Kotlin compiler cannot use these features from the Gradle model. So the JetBrains came up with different approaches, right? And the most recent one was to extract and store the application binary interface of the compilation class path of the dependencies of the Kotlin compiler, meaning that it's going to be faster in reusing the outputs when we are doing incremental builds. So the problem with the Kotlin compiler was like, if you are using a non-Kotlin model and you have chains, you were triggering like a full recompilation, right? So with this new approach, if you have an update of one dependency that is a jar, you don't need to do a full recompilation of your code because there is a track of the references of the methods. Well, sorry about that, but well, so these properties use class path snapshot, right? That's default since 1.8. And the work of extracting and storing the application binary interface of the dependencies is done by these transforms that I showed before. Class path, snapshot, properties, or transform. There is something interesting if you check the build scans, and you will have dependencies that they are related with the build class path, and dependencies that they are related with dependencies of one Kotlin compiler. Definitely, I will recommend you to take a look. In terms of the implementation in the Kotlin Gradle plugin, same approach. We register one transform from where? From jar to class path snapshot, and then we are triggering the transform by saying that, hey, all the artifacts of the class path configuration needs to fit in this condition, class path entry. Okay, so we have seen theory, implementation. They're using in our Android builds. So now it's moment to say, well, what we can do with this information, right? So it's nice, right? So for a presentation, but can we have some opportunities to use this information to find optimization in our builds? And this is like this section about. The first case study is the case of the material icons dependency. And yep, we start again with now in Android. And as build engineers, so I think that a simple approach to analyze the opportunities to optimize the performance of one project is just analyzing the longest task in the build. Like here, for assemble debug, we can see that the Dex demo debug is taking 3 minutes. Okay. So the next action on the investigation was to look the details of the execution of the task. You can see that the fingerprinting, 1 second, so far so good. Task action execution, 15 seconds, build cache, everything okay. But executing the artifact transforms was 3 minutes. Something is going on. So the next point on the investigation was go to the transform executions in the build scan and order by duration. And we have 2 specific transforms with crazy times, dexing with class path transform, 2 minutes and 1 minute for one dependency. Remember that before I told you that on the details of the transform, we can check which task is requesting this transform, and guess what? It's the same task that is the longest in the build execution. Additionally, we check what's the details of the transform, and we see that the action execution, it was 2 minutes. And again, so I'm talking about the execution of one single transform of one dependency, and it's taking 2 minutes. The cache artifact size, 7 megs, it was something as well to be maybe concerned, but well, let's continue. Our next step was to analyze this dependency, right? Because something goes wrong. And we noticed that these icons extended was about 30 megs. Well, so let's see. Additionally, we have 11,000 classes. So there was something there. At this point, we wanted to maybe there is a problem with the indexing with class path transform, or maybe there is a problem with the dependency, right? So let's see. We choose the way to evaluate what's the cost of the same dependency for different transforms. So we analyze ASM classes transform. The duration was 16 seconds, not a concern. But this single transform on this dependency was taking more than 41% of the time. On another one, Jacoco transform, 31%. Definitely, there is something with the library that is affecting the execution of the different transforms. So we apply a simple experiment by removing the dependency and providing manually the icons and code required in the module core design system in the now in Android project. The results were quite visible. In terms of duration, we reduced by 46% the task duration and 50% in terms of the artifact transform duration as well. That's good, but what about the overall build time? We did an experiment, assemble debug, 100 iterations, fresh agent CI for CPUs, and those were the results. 15% decrease in the build time and 22% in execution time, just by removing the library and providing manually the code required. So I mean, of course, I know that this is not going to apply to everybody, right? But just wanted to mention that following the track of the material icons, so we reduced this time in this project. You have the build scans and available, so in case that you want to follow the investigations. The second case, or the second case study is what the Hill is going on. Hill, that's something that we didn't mention before. It's providing to transform, copy, and aggregated package transform. If we analyze build scan, one dependency, we can see that by the namespace, we are executing two transforms with, for this specific dependency. Same exercise, if we check the task that is requesting this transform, we see the Hill aggregate depth debug. So far, so good. Okay, so something that I want to mention that always we are focusing on external dependencies. In this exercise, we are going to focus on references in the same project. So I have a model that is called OLIP, and from my app model, what I can see in the build scan is that I have a transform, a project transform from the app model, well, sorry, from the lib to the app model, right? You can see, well, it's coming from jar from Dagger and aggregated jar. So what I want to say is that besides the external dependencies, when we have project dependencies, we are applying transforms to those dependencies as well, right? If we analyze the, again, now in Android, assemble prod debug, we are seeing that we have as many as transforms for the aggregate package transform as relations we have from the app model to the other models. Okay, let's pick another generate project with 321 modules. So following our theory, the expected project transforms are 3 per number of modules. The transforms are identity transform, that comes from the Undergate plugin, implementation detail, copy transform, and aggregated package transform. If we execute assemble debug, we can see that we have 963 artifact transforms. So our formula is correct. So what happens if we execute test debug unit test? That we have 100,000 transforms. What? That we have 100,000 transforms. Yeah, give me a give. Okay, so what's going on? right? So for the same project, when we are executing the test variant, we are getting like a crazy number of transforms, right? And sure that this is affecting the performance on our build. The reason is because we are creating 300 tasks of the aggregated dependencies from Hilt. And we have an explosion of transforms from different models. Not from the app model now from all the layers, all the different models. The reason is because the Hilt plugin is registering the task, aggregating task, when it's the application, right, only for the application variant. But when it's an Android library, it's registering it's creating the task and registering the task for the test variants. So that means that if I'm executing a test variant from the general test variant, I'm going to create as many as Hilt components for the test scope in my test. And there is nothing wrong with that because maybe you need to create a Hilt component in your test variants, right? But what we can see is that it's enabled by default, this option, and it's not always true. Is you're not required to build a Hilt component inside your test, you can disable. So we did a quick experiment by disabling this property only in the Android libraries, not in the app because we need that. And the experiments were, there was not very appealing, right? But just by disabling this on the same task, we're seeing an 8%, well, 7% decrease build time and execution time. Again, something to measure. And of course, these projects are very straightforward, so the results can change depending on you. So and with that, you have the results of the build scans too. Going back to Nelson.
Thanks, Inaki. So yeah, we have some very creative ways to improve your builds and analyze your builds with transforms. I have even more exciting ways to analyze your builds with transforms, but what I wanted to mention too is, so we used to get all these reports from customers that their tasks had a very long fingerprinting time. So I just wanted to dive into that because it's a bit of a red herring. So when you look at a build scan, as we saw earlier, you have the fingerprinting input time, you have the task action execution, you have the build cache time, and as well as the executing artifact transforms time. For this task, just to note, the fingerprinting inputs time was 1 second, and the executing artifact transforms time was 1 minute and about 6 seconds. You can go to the transform request tab and see all those transforms that were run that sum up to 1 minute, 5 seconds. Yeah, but yeah, what did this look like before transforms were captured in the build scan? So you can do a quick experiment. There's actually a secret flag to disable capturing of artifact transforms that you can do in your settings.gradle file. You can remove the artifact transform cache with this command, and then you can rerun the same build with the same task. What you see now is really interesting, that the same task, which had 1 second of fingerprinting inputs time, now shows 1 minute and 15 seconds of fingerprinting inputs time. This is the same exact task, the same exact build. There's no difference. It's just that this build scan is attributing the artifact transform execution to fingerprinting inputs. So yeah, just to compare, this is what it looked like before. Total duration is about the same, 1 minute, 20 seconds, 1 minute, 24 seconds, but yeah, all the time goes to fingerprinting inputs. So yeah, just a little bit of a gotcha when you're like going down the rabbit hole and investigating artifact transforms, or if you disable capturing of it. All right. So let's go into a little bit of a different topic, but also related to transforms, which is the Develocity API. Develocity now supports artifact transforms in the API. There's a lot of new stuff we're adding to the Develocity API all the time. And yeah, in the latest release, this was, in my opinion, the most exciting because it allows you to do some really cool cross-build analysis. Yeah, here's the endpoint. There's the doc, if you want to look at it. Here's just a bit of the information that's in the API. The Develocity API, by the way, is OpenAPI standard-based. So you can generate models and clients for doing any sort of analysis that you want to do. But even better than writing your own client is actually another feature that in Devvelocity that I also am very excited to share with you, which is called Devvelocity Reporting and Visualization, which is also part of Devvelocity 2024.1. And it's basically a set of Grafana dashboards that are in addition to the standard set of dashboards that Devvelocity has. I know we didn't do a Devvelocity demo, but yeah, these dashboards are really cool, but because they give you all sorts of things like build cache hit ratios, project level details, migration. If you're doing a CI migration, you can create percentages and graphs from that. And yeah, how does it work? Aside from the out-of-box Grafana dashboards, basically you have to set up your Devvelocity to export the data that's available via the API. So that's a new functionality that came out. It's really easy. You check a box, and then all the data is exported. And then it runs custom queries via Trino and or Athena, depending on the setup. So that allows you to, instead of writing your own client to extract data out of Devvelocity, you can just run a SQL query and do analysis on things like transforms. So we actually did a really interesting analysis on the Devvelocity build and also the Gradle build tool build on the transforms that were run, whether they had positive or negative savings, whether they were up to date, what environment they ran on. And yeah, we found actually, I mean, this is not in this screenshot. I can't share with you the details of what we found, but yeah, in the Devvelocity build itself, which is not open source, there was one transform that was basically just really always negative savings, whether it was coming from the local cache or on CI or remote cache, it was just always negative. So yeah, this sort of analysis is now possible. As well as you can also do this analysis on tasks, just so you know, but since the topic is transforms, wanted to share that. Yep. So we're running out of time, and luckily we finally got to the last slide. Thank you all for sticking with me. I wanted to point out that we just launched the DPE University, which includes a starter grade. So there's an intro to Gradle course, there's an intro to Maven course, there's a build caching course, authoring Gradle builds course. So the content is great. We have Akshay, he's awesome, and he built a lot of the content there. So definitely check it out if this talk was very advanced for you and you want to learn more of the basics of Gradle, yeah, definitely go there. If you're interested in some of the Devvelocity features that I shared, go to that link for Devvelocity trial. We're also hiring at Gradle, gradle.com/careers. And yeah, if you have any questions, feel free to visit our booth right out there. And with that, thank you very much.